So in last class we have seen the cloning. We have started with cloning and different types of approach to clone an object. In that we have seen how to clone an object with a method, or how to clone an object with a constructor, and what happens when you just assign one reference variable address to another reference variable, or what happens when you copy one primitive type value to another primitive type value, right? And all these things we have seen. So today we will directly start with clone method of object class, right? So we have a class student. Same example I'll take again. Say int sid, string type, some name, and take a constructor to initialize this instance variable sid of type int, string type name, right? So this is this dot sid is sid, and this dot name is name, and I will take a method here to show the information. Say void show info, right? sid one tab space and right. And in another class, say class test, and in test class we have a main method main, one string type argument. So you are creating one student, s1 is new student. This is one object created, and we can see the information also for that. So this is s1 dot show info. But when you are creating the object, default constructor is not available, so we need to use the parameterized constructor 100 and say some name abc. And I'll take one default constructor also. So here I am writing some SOP statement, student int and string argumented constructor, right? And take one default constructor also. Student constructor, right? Settle this. Now this, if I just compile and execute once, say test class we are compiling, it is having the main method, and if I execute, what JVM will do, JVM will create one object with the content 100 and abc. The object address will assign it to s1, and on that show info function when we will call, it has to print the content, right? So the memory architecture for this will be, say this is the memory, right? So this is method area, stack and heap, and this, say here the main method is loading main from here till this. Inside the main method, first you have a local variable s1, local reference variable s1. So s1 should be, this is, so this is s1, and s1 has to point to an object. This is s1 reference variable pointing to an object, and object is this. So object is this. And in this object, two instance variable sid and name memory has to be allocated. So sid is sid memory is allocated, the value is 100, and the name memory is allocated, the value is some abc, and the address of this object is say 1020. This object has to assign to s1, this is 1020, right? Now the reference variable has to point to this is pointing. This is pointing here, right? So now this is done. Now this object has to be cloned. It has to create a new object from this object with the same content. Previously for this we use inside the student class we have used method or we have used constructor, and we did that explicitly. Now I don't want to do that. What I want is, in object class you have already one clone method, and that clone method has to be called, and clone method has to copy this object, and the newly created object address has to be returned into, say, student s2. It should be s2 is equal to s1 dot clone, like this. This clone function, whatever task we did previously with explicit function or constructor, the same thing now has to be done by this clone function, which is already designed in object class in lang package, and that only should be called here. But to call this clone method here, clone method is an instance method, so we need to call with the object reference s1. We are calling with the s1. But the problem is, clone method, where is the clone method here? Here no clone method. But student class by default extends object class, and inside the object class clone method is available, and it is inherited to student class, and this is what we are calling here clone. Inherited clone method is calling on s1 reference variable. But the problem is, clone method design is clone method signature. If you want to check the clone method signature, open the command prompt. Here you type java p java.lang.object. Java P is the Java decompiler, and Java P will decompile the object class, and whatever contents are there in object class, whatever members available, all those members will be listed here. So in that list you will have one clone method which is inherited. So the clone method is this one. Clone method is this. And just copy it, and I'll put it here. This is clone. Clone method signature is protected native java.lang.object is the return type, and function name is clone. It throws one clone not supported exception, right? This is the clone method signature. Now the important point you have to notice here is the clone method is protected, and protected member outside the package, how will you access? For example, assume we have a package P1, and under P1 I have a class, say class ABC, or you take some class A. In A class you have a method void show, or say it is okay show only. Show method is having some implementation here, and show method is protected. Now if I want to access one more, if I want to use this show method which is protected in another class, so the class is B, and B extends B extends A. Both A and B class is in the same package P1, and inside this B, this show method is inherited. Show method is inherited to class B. Now somewhere, say in class test, if I have a main method in class test, static void main, and say test class is also in P1 package. All these three classes are in P1 package. And in A class you have a function show which is protected, that is inherited to B, and in test I need to create an object of B. B1 is equal to say new B, and here B1 dot show. If I try to call like this, it is possible, you can call it, no problem, it is fine. So protected member inside the package, if you access inside B directly, say inside B you have one more method void some M method, and inside M if I try to call this show, which is inherited, then directly you can say show, no problem, this is fine. Protected member inside the package, protected member inside the package, in subclass directly you can access, in non-subclass with subclass object reference also you can access, no problem. Means protected member inside the package, inside the same package, no restriction at all, you can use directly, no problem, it is fine. But when it is in different package, for example, so I have a class C and class C extends A, but A is in different package and class C is in package P2, class C is in package P2, P2 package class C extends class A, but A is in P1 package. Now you have to import, you have to write import P1 dot A, but for that P1 should be public, okay, P1, sorry, A class should be public, okay, it is public, fine. Now C class extends A, which is in P1, and in C class suppose void M1 method is there, and M1 method wants to access the show which is inherited from A, which is inherited from A. Then how will you access? You can access show. This is show, directly you can access. But when you are writing here show, actually what is the meaning? It means it is this dot show. This dot show means, this means current class, current object. So outside the package, protected member outside the package with subclass with this keyword you can access, no problem, it is fine. So this is okay, it is fine. But when it is, so suppose here I have one more class test. In this test also I have a main method. Test also is having one main method, this. And inside this main method will create an object of C now. So here I am creating an object of C, C1 is equal to new C. And C1 dot show, which is inherited. C extends A. And A is having method show. A is having show method which is protected. This is inherited to C. Inherited to C, so directly here you can access. But this inherited instance method, if I try to access inside the test with C object, then this is not okay. You cannot. Now you notice again very clearly. In package P1, you have class A in that protected show method. Inside the same class, same package, subclass, you can access directly. Again here also it is actually this dot show. Same package subclass, this dot show, okay. Same package non-subclass test, inside that subclass object reference B dot show, that is also fine. Right. Now again this same method only of P1 package of A class inherited in some other class in different package P2. In this class, inside the class, this dot show is okay, but in this P2 package test C class object reference show is not okay. Not okay. Now you come back to our case here. Student extend object. How is the object class? Object class. Class object. And actually it is public. And this is package java.lang package. Inside this java.lang package, you have this method which is protected. This is protected, and this student class will take assume in package com dot sesam t1 tutorial 1 in this package. Now protected member inside the same package subclass access, different package subclass you can access. Protected member, same package subclass you can access, different package subclass you can access. So this object class clone function is inherited to a student, different package subclass you can access. So suppose here if I write void some disp method, and inside the disp method here if I write this dot clone, okay fine, you can access it, no problem, because it is different package subclass you can access clone. But inside this test, say here if I write s1.clone, this we cannot access. Here one more point I need to add. In different package subclass you can access, but different package non-subclass you cannot access. Different protected member, different package subclass you can access, different package non-subclass you cannot access. Now come back to this. Protected member, different package subclass you can access, this is inside the subclass, but different package non-subclass, this is not okay. This is not okay. Non-subclass, not okay. You cannot write this statement. Protected member, say test and student, both is in this package. Test and student, both is in the same package. In student, because it is subclass, so directly you can access clone. And because this is non-subclass, you are accessing with S1 object, and this class is test. It is non-subclass. Actually, test is also having extends object. Test is also extending object, but with the object reference with which you are accessing clone function is not of type test. It is of type student. Means you can say the clear definition is protected member outside the package you can access with the current class and subclass object. Both the condition. Protected member outside the package, if you want to access, you have to access with current class and subclass. The object with which you will access the protected member, that must be accessed with current class and subclass object. Now you check this condition here, it is matching or not. This means current class object, and current class object must be of subtype, current type and subtype, both the conditions should be matched. This is of type B and B is a subtype of A. Here you verify this is of type current C and C is of type A. But in this if I try C1 is of type C, but the current type is test, so it is not working. One condition is not matching, it is not current type, it is subtype but it is not current type. Here both the condition is matching, it is current type and it is subtype. Same way here, both the condition is matching, it is current type and subtype. And here condition no need to verify because all these are in the same package. If the package is different, then only this condition has to be matched. In different package, protected member outside the package, if you want to access, you have to access with the current class and subclass object. Because of this reason, inside this main method here, we cannot say s1.clone. Then what you have to do? How will you access? We cannot directly, previously we have designed here void or object something like this. In last tutorial, object get cloned object, and it was doing all this operation. It has created object and object is returned. Here this condition was not verified because it is we have designed and we have called inside the main directly. Directly we have designed, we have called the function. Now clone function which is inherited, that inherited function only has to do this, but inherited function is protected. From here we cannot call From the main method we cannot call clone function, but from here we can call. So what we will do is, we will take another method here. We will take our own method, say get cloned object. Get cloned object is our method. In previous tutorial, in our method we have created object, we have copied the content, we have returned. But now what I will do is, on this get cloned object only, I will call this dot clone. In get clone object function, you are calling clone function, which is protected, which is inherited. In the same location you can call it. In the same package, same different package subclass you can call clone. So here we are calling clone. So this will create a cloned object. But from the main method you cannot call clone. So what you will do here, you will call student s2 is equal to s1 dot get cloned object. Get cloned object. This part is similar like previous only. Previously what we did, get cloned object we designed and we have created the object, we have copied. But now difference is, we have called get cloned object only, but get cloned object is not creating an object, not copying the content, not returning the address. Get clone object is calling the clone method which is inherited from the object class, right? And this returns this dot clone, right? It will this you will call the get cloned object function, and get clone object function will call this dot clone, because you can call it from here and this object will be returned. Because this function is having a return type, so here it should not be now void, it should be object type object will be returned. And now this function is returning object type object. Get clone function return type is object. Clone function creates a copies the object and it returns that. This complete operation is returning a object type object address, but actually the object is of type student, so I am storing into student s2. But super type reference variable you cannot store into subtype reference variable directly, so here you need to typecast that to student type, this. So this is done through the clone function. Cloning is done. And after that, here again if I say s2 dot show info, s2 dot show info, now s2 dot show info will be printed. Now what will be the diagram now? How will be the diagram? Now if I compile test and if I execute, till this is done, and show function is called. When I will call show function, this SID and name ABC and 101, this is going to print by the show function, right? Now in this, when I will say s1 dot get cloned object, it has to copy this object. This object has to be copied. Who will copy that? You are calling get clone object function. Get clone function, get cloned object function calls the clone function. Clone function copies this object and the address will be returned. This object will store into S2, typecasted and stored into S2. So now in the diagram, inside the stack in the main, you have again a local variable which is S2. So this is S2 and this object is copied. This object is copied here. This is the object copied. And this is copied. So this is S2. The address of newly copied object is say 4020 or 40. So this is 4040. The content SID is copied as it is, so it is 101. Name copied as it is, so it is ABC, right? Done. Now you are saying s2 dot show. Now show will be, it will print again the content 101 and ABC. Now if I execute this program, I'll just copy from here till this, copy this and put into IDE. So in last class we were getting the problem with I'll just put this in comment. this dot clone. Last class we are not able to do that, so just to overcome with this, I'll just put that as obj is equal to null first time, or to make it more clear, and this we cannot do. Right, I'll take one more package and one more class. So package com.clone.p3, class is test, and done. Right, so this is class student. It is having an object, extending object, fine, and this class should be, test class should be public. Now student S1 object is created with this content, show info, and here we cannot call. It is a compilation fail. Clone function we cannot call. So I'll just put in comment. And then what we did to overcome with this, we call get cloned object. What get cloned object is doing? Get cloned object is calling this dot clone. Here it, this dot clone you can do because it is current class and it is current type and subtype, both is fine. Next. And you are saying show info, and after that finish. Done. Till this is done. But one more small problem is there. It is giving here one underline, means it is an error. Okay, we will come back with this. First you see whether it is working fine or not. I'll come back to this. I'll just write here implements clonable now. And where you're writing this, we'll discuss that. Exception. Right, so till this done. Now you just run it and see once. It is fine, output is fine. But how will you check whether it is working similar like this diagram or not? Two different objects is created or not? How will you know? So to do that, you can do one thing, very simple, easy way. Print S1 and print S2. If different address, it is two different object. Run it again. It is fine, it is two different address. Two different object is created now. Or we can do one more thing. We will modify the content of one object. Here it is modified. So this is after modification or after changing the value. And here we will change. So we are changing the value of S1 object. S1 dot SID is 1099. and s2 dot s1 dot name is equal to some xyz. After that, again s1 dot show info and s2 dot show info, s1 dot show info, s2 dot show info. Now, according to this, what changes are there in the diagram? S1 value is changed. Now S1 is not 101, SID is not 100, and name is not ABC. It is actually now, this is not 101 and this is not ABC. It is now, this is 99 and this is XYZ. And then you call the S1 dot, here we are calling S1 dot show info, S1 dot show info after changing, and again S2 dot show info. Means S1 dot show info should be 99 and XYZ, S2 dot show info should be 101 and ABC. That remain change because it is two different objects. So if you modify one object content, it is not going to affect the other, it remains as it is. So this is what we did here in the program. You just run it and check. It is done, it is cloned. Means it is perfectly cloned, no difference, it is fine. One more important point you have to notice, in last class what we did, when we have created the object with the object, in last class what we did, we have not used this clone method. Instead of this clone method, the implementation we have written, we have created the object by using default constructor, and we have copied the content of one object to the cloned object. But now the same thing is doing by clone. But in last example, last tutorial, what we did when we have did like this, to create the object by using default constructor, inside this method what we did in the last class, instead of say this dot clone, what we did in the last class, I'll write here again. What we did, student s1 is equal to new student, one object is created, or it was just s, suppose it was just s, a student s is equal to new, and s dot sid is equal to this dot id, like this we did, s dot name is equal to this dot name, like this. We have created an object explicitly by using the constructor we have cloned. So the output was, because you have used the default constructor, so default constructor was also used, it was giving this output, student default constructor. And this output also was there because this you are doing, this constructor you are calling from the main method here. So both the constructor was used explicitly when you are writing, both the constructor was used. But the clone function will not use this technique, it will not use the default constructor. What clone function does is, in this memory, whatever object you have created here, this object it just copies and pastes into this location directly. It will not create a new object, it will not copy the content, not like this. This object directly will be copied into this location. It will not copy, it will not create a new object. Existing object will be directly copied to the another memory location. In two different memory locations, the same object will be present. It will not create a new object by using default constructor, and it will not copy the content because of this reason. Now if you notice the output, this default constructor call should not be there, default constructor should not be used, this statement should not be printed. Now you notice the output once again in the console, you can see here default constructor is not used anywhere, but object is cloned. From this change and from this change you clearly understood that the object is cloned, but the default constructor is not called, means newly object is not created. So this is how clone function actually works, default constructor will not be used. This is one major difference between when you clone actually and when you clone by using clone function of object class. This is one very important difference, right? Clone function will not use the default constructor to clone the object, and when you write explicitly this code, you have to use the default constructor, you don't have any other option. You have to use the default constructor to create the object, and you have to copy the content, but clone function does not do the same thing. This is one very important difference when you clone explicitly and when clone function clones. Another important difference is, in last class when we have cloned, we have written this code directly and object is cloned and copied, nothing else. But now when clone function does this, clone function has to just copy this object, it has to put into this location, For that, clone function has to verify certain condition. Clone function directly will not copy this and directly will not put into this location. The object should have certain quality, certain condition it has to match, and then only clone function will copy this memory and will put into here. What is this condition? The object should be eligible for cloning. Sorry, here what we did, we cloned this object and we have copied here, right? Sorry, no, it is okay. S1 is this one and S2 is this. This is clone, fine. So S1 object, when clone function will clone and when it will put into this location, the S1 object should be eligible for cloning. It should be eligible for cloning. And how an object becomes eligible for cloning for the clone function is, the object which clone function is going to clone, that object should be subtype of clonable interface. Means the object which clone function is going to clone, this object should be an instance of clonable interface. Now how will you make it instance of clonable interface? How this should be an instance of clonable interface? The rule for making an instance, suppose a class hierarchy is like this. Say class A and class B. Whatever object you create for A or whatever object you create for B, all the object of A are the instance of A, all the object of B are the instance of B. Now, if the classes are in an inheritance relationship, say B extends A, then all the objects, whatever object you create for A class, say I am writing here like this, A1 is new A, and one more, A2 is equal to new A. 2A object is created. Both A1 and A2 is called as an instance of A. But if I create an object of B, B1, new B, and B2, new B. B1 and B2 are the instance of B. At the same time, B1 and B2 are also the instance of A also. A1 and A2 are only the instances of A, but B1 and B2 are the instances of both A and B, right? So if you want to make something like this, some object should be instances of some other type, then what you have to do? You just have to make that as super type. Your class has to extend that class, or your class has to implement that interface. So now, suppose I have an interface IN. IN is an interface. Say this is here. IN is an interface. Now I want B object should be an instance of B. It should be also an instance of A, and also should be instance of IN. Then B class has to extend A, and it has to implements IN. Now whatever object you will create of B, that object will be an instance of type A, instance of type IN, and instance of type B. These B1 and B2 are the instances of B, instances of A, and instances of IN, both, all three. Means you can say here something like this: subclass instances are also the instances of super type. You can say subtype instances are also the instances of supertype, but reverse is not okay. Supertype instances are also not instances of subtype. For example, if I create an object of A, that will not be instances of B, but if I create an object of B, that will be instances of A. Or more clearly, you can remember it in this way. Say class employee. One more class is there, say class HR. HR extends employee. Now, all the HRs are employees, but all the employees are not HRs. All the HRs are employees, but all the employees of a company cannot be the HR. So all the subtype instances are also the type of supertype, but all the supertypes are not subtypes. Means subtype instances are also the instances of supertype, but supertype instances are not the instances of subtype. Right, now come back to this object. Now when clone method will clone this S1 object, it has to match the condition. The condition is S1 object which is cloning by the clone function should be an instance of clonable interface. In java.lang package, you have an interface that is clonable. This is an interface in java.lang package. In java.lang package, you have interface clonable. It is an empty interface, nothing is there, empty, like this, empty, nothing is there. Empty interface is also called as marker interface. Right, so any object, if I want to make an instance of this clonable interface, what I have to do? Suppose I have a class hello, and I want to make whatever object I will create for hello class, all that object should be instances of hello and also should be instances of clonable interface. Then what will you do? You just implement clonable. Now whatever object, say here hello h1 is equal to new hello. Now this h1 object is an instance of hello and it is also an instance of clonable. Now in this diagram, when clone function will try to clone this object, it will verify that object instance of clonable interface or not. Object is of which type? A student type. Now I want to make all the student type objects should be also the instance of clonable interface. Then what will you do? Simply, student class has to implement clonable interface. Student class has to implement clonable interface. That's it. Now the condition is matched. Now this object is eligible for cloning. Clone function will not do any complaint. It will not complain anything. It will directly copy and paste. But before doing this, clone function will verify whether the object is clonable or not. Okay, it is clonable because this class implementing clonable interface, it is clonable. Now it will copy and paste. If it is not implementing clonable interface, now come back to our example. Here, I have already written implements clonable. If I don't write this part, implement clonable is not there. Then clone function, when clone function will verify, when this clone function will verify that this current object which is going to be cloned is clonable or not, it will check, okay, it is not clonable. If it is not clonable, then it will give an exception, clone not supported exception, runtime exception. See this, clone not supported exception means the object is not eligible for cloning and clone function cannot clone it. Right. So what you have to do? Before, if you try to clone any object, you must write implements clonable. You must write implements clonable. You have to write it. Otherwise, the object will not be cloned. Now you run again. It is cloned. No problem. It is fine. It is cloned. Okay. So this is two different important points you have to remember. What is the first one? First one is when clone function will be used, default constructor is not required. Clone function will not call the default constructor or it will not create a new object. It will copy the object. This is one point. Another point is when clone function will try to clone any object, it must be subtype of clonable interface. It must be eligible for cloning, and that you have to do by using implements clonable interface. Otherwise, clone function will not work. But in our case, in last tutorial, what we did, we have not verified anything, whether it is clonable or not. We didn't check. We directly create an object, we copied and we pasted, done. Right? We didn't check anything. But now clone function will check. Clone function will verify whether it is eligible for cloning or not. If it is eligible for cloning, then only it will be cloned. If it is not eligible for cloning, it will not be cloned. Stop there. Fine, done. But okay, one more important point you have to write. When I have used here this dot clone, I have written here throws exception. Throws exception. Okay, if I don't write and you save it, say this is giving an error. It is a compile time error. It is a compile time error. To overcome with this error, I have written here throws exception. This. Now, when you will write here throws exception, to overcome with this problem, if I don't write, then this gives a compilation fail. So to overcome with this, what we did, we have written here throws exception. We have written here throws exception. But when I will write here throws exception, inside the main method you notice again, here also I have written throws exception. Here also I have written throws exception. Right. If I don't write again here, now this is giving a compilation fail. So what I have to do, I have to write here also. Sorry, this. So this is now again exception related concept. You remember these 3 points now. One is, when you will use clone function, default constructor will not be used. Object must be eligible for cloning, and you have to write here throws exception. You have to write here throws exception. Why this you have to write? We will verify that with exception handling concept, exception handling topic. One more important point you have to notice is, when you are writing the code for cloning, you are not doing any validation check whether it is eligible for cloning or not. You are directly cloning, but the clone function does that. It has to check, right? It should be eligible for cloning. And another important point what you have to remember here is,